We're starting section 1.5, which is still quadratic equations, but we're going to apply them to geometry problems so that you can see how they work in application. So we're going to start off with a piece of machinery produces rectangular sheets of metal such that the length is 3 times the width. So here's our width right here, and I'm going to see if I can get this without, it's really hard to draw straight lines. So here's our width right here, and then the length is this one right here. So if our length is 3 times the width, and we don't know either, then we'll call one of them x, and the other will be 3 times that, so that will be 3x. And then they're going to cut these little squares right here. So equal size squares measuring 5 inches on a side can be cut from the corners. So they're just going to cut these little 4 5 by 5 corners off, and then that way you're able to fold up the sides so that it creates this 3-dimensional shape from this flat piece. Now, once you create a 3-dimensional shape, you have a volume, and that's what you can fill it. So the volume of a rectangular prism is length times width times height. So this is the formula that we're going to use. So what we know is the formula, and we know the actual volume. We know that the length is 3x minus 10. We know the width is x minus 10, and we know the height is 5. So we're going to plug these things into this formula here, and we're going to go through and solve it. So we've got, get rid of that. Okay, for whatever reason, there's a box. Okay, so we're going to go volume is length times width times height. Our volume is 1435. Our length is 3x minus 10. The width is x minus 10. And the height is 5. All right, so you would go through and distribute, do your double distribution like we did before, where we did 3x times x, 3x times 10, then 10 times x, and 10 times 10. But first, since we're multiplying by this 5 out here, let's just divide both sides by 5 so that we can get rid of that 5 there. So 1435 divided by 5. I may have to push pause and go run and get my calculator. So we got 1435 divided by 5, which is 287. So we've got 287 equals 3x times x is 3x squared. 3x times negative 10 is negative 30x. Negative 10 times x is negative 10x. And negative 10 times negative 10 is 100. So now let's combine like terms and start rearranging this so that it's equal to 0. So we'll leave it for here. So we get 3x squared. These two are like terms because they're just x, so that's negative 40x plus 100. All right, so now let's subtract the 287 from both sides. So we get 0 equals 3x squared minus 40x minus 187. All right, so now if we do the x method that we did on those ones previously, 3 times 187, so we get 3 times 187, which is going to be a negative 561, and then we bring the negative number down. So you go through, since we start with a 3, we're going to put 3's here. We go through and list our factors of 561, like 5 times 561. We know 3 times 187. And we're going to go through, and you'll find several others as you go through the process. 187 divided by, let's see, not 187. It was 561 divided by 11. So if I did 11 times 51, so 11 times 51 will give me 561. And if I did negative 51, that'll give me negative 40, because negative 51 plus 11 is negative 40. So we're going to go 11 and negative 51. So now this will not reduce, so this is going to be 3x plus 11. This one will reduce, okay? This will simplify. 3 will go into itself once. 3 will go into 51 17 times. So this one becomes x minus 17. And all of that is equal to 0. So now, just like the last section, we're going to take each piece. So you get 3x plus 11 equals 0. So subtract 11. So 3x equals negative 11 and divide by 3. You get x equals negative 11 over 3. All right, so I'm going to tell you right now, when you get a negative answer when you're doing a geometry style problem, go ahead and plug it in. So if this number right here were negative 11 over 3, so 11 over 3, that's 3.7. So this would be negative 3.7. If I were to plug in a negative 3.7 minus 10, that would be negative 13.7. That's not going to work because you cannot have a width that's negative length. Length can only be positive. So I know that this answer I just got, this one's not going to work. Okay, this answer is not going to work. But I've got this second piece. And if I add 17 to both sides, I get that x is 17. So now if I go up here and instead of plugging in a negative 3, what if I plugged in 17? 17 minus 10 is 7. So that means this is 7 units long. So this piece that they're producing is 7. So that means this is 3 times 7 because we just found that x was 7. So this is 21. So now you know that this sheet of metal is 7 by 21. So it says find the dimensions of the original piece of metal. Well, we did. It is 7 by 21. So our length is 21 and our width is 7. And I apologize that this is sloppy. It is really hard to write on this thing today for whatever reason. All right. So I'll give you a second to look at that. All right, so now let's move into our next piece here. All right, now we're going to look at the Pythagorean theorem. When I was in high school, my teacher, I remember she used to stand at the door and would quiz us over what the Pythagorean theorem was every day. So you have a squared plus b squared equals c squared. It only works on right triangles. It doesn't work on any other triangle. You have to have a right angle for it to work. So you have your a and your b, which are your legs. The hypotenuse is your C. It's always going to be the slanted side. It's always the longest side. All right, so when you're looking at this triangle right here, it says a piece of property has the shape of a right triangle. Technically, they should have a right angle here telling you that it's a right triangle. The longer leg is 20 meters longer than twice the length of the shorter leg. So if my shorter leg is x, then the longer leg is 2 times that plus 20. So that would be 2x plus 20. The hypotenuse, which is this one, is 10 meters longer than the length of the longer leg. So you would just add 10. So you would do 2x plus 20 plus 10, which gives you 2x plus 30. Now it says to find the lengths of the sides of the triangular lot. So we need to find what x is so we can actually see the dimensions of our property. So we're just going to plug that in and see. So we've got a squared, so we'll call this a, we'll call this b, and this is our c. And let's see if we can make this a little skinnier. All right, so we've got a squared plus b squared equals c squared. So all I did was plug in the dimensions for a, b, and c. So this is x squared plus, I am going to do the 2x plus 20 squared. That means 2x plus 20 times 2x plus 20. So this squared means you have to do whatever is inside. You have to multiply it that many times. So we've got 2x times 2x, so that is 4x squared. We got 2x times 20, so that's 40x. And we got 20 times 2x, so that's another 40x. And then we got 20 times 20, so that is 400. Equals, now you're going to do the same thing with the 2x plus 30. So 2x plus 30, 2x plus 30. So now we got 2x times 2x, so that's 4x squared. 2x times 30, that's 60x. And I'm going to erase this piece here so I can use the space. Now we got 30 times 2x, so that's another 60x. And 30 times 30 is 900. All right, so combine your like terms all the way across and then start moving everything around. So I have x squared and 4x squared, so that is 5x squared. 40x and 40x, that is 80x, and then 400 equals, over here I only have the 4x squared. The 60 and the 60, that's going to be 120x. And again, I'm going to erase this out of my way. And then plus the 900. So I'm going to move everything on the right over to the left so that it's equal to 0, so that I can do just like the last problem where we factor it out. So I'm going to subtract the 4x squared. I'm going to subtract the 120x. And I'm going to subtract the 900. So all of that cancels out, leaving me with 0. All right, 5x squared minus 4x squared is x squared. Now I've got 80 minus 120, so that's negative 40x. And then you've got 400 minus 900, so that is negative 500. So now we can do the little x thing here. Since there's a 1 here, there's just 1s in the bottom. Negative 40 goes here, and negative 500 goes here. So we need to find our factors. And I'm going to go up here and pull up my little cheat sheet here. Where did my cheat sheet go? There we go. All right. So the numbers that are going to multiply together to give you, so think about it, you've got 1 times 500. You've got 2 times 250, 5 times 100, and you just start going through the list, and you'll get down to 10 times 50, because if I took 10 and subtracted 50, I would get negative 40. So 10 and negative 50. So now this piece here, this is going to be x plus 10, and this is x minus 50 equals 0. So take each piece, x plus 10 equals 0, subtract 10 from both sides, x is negative 10. So remember what I said about if you get a negative answer in geometry that you need to check it. If I go back up here, and if x is negative 10, that means this length is negative 10, so that's not going to work. So we know that this answer is not valid for our question. But we have a second part because we have x minus 50 equals 0. So if we add that 50 to both sides, we get x equals 50. And that is a positive answer. So now if I go up here, I know that this is your x, and I will erase all of that I've scribbled on. So I know that this is my x, so that means it's 50 because x is 50. Now this side is going to be 2 times 50 plus 20. So 2 50s is 100 plus 20. That's 120. So this side is 120. And then this is going to be 2 times 50 plus 30. So that's 130. So the dimensions are the short leg is 50, the long leg is 120, and the hypotenuse is 130. All right, so all it wanted me to do was find the lengths of the sides. We did that. That's 50, 120, and 130, so we are good to move on. Now, the height of a projected object. All right, so if, where did it go? So if a projectile is launched vertically upward from the ground with initial velocity of 100 feet per second, so that's how fast it's moving, neglecting air resistance, its height, s, is going to be in feet above the ground, t seconds after projection given. So here is our quadratic that they've given us. So the height is -16 times squared plus 100 time. After how many seconds to the nearest hundredth will the projectile be 50 feet above the ground? So what is the 50 representing? Is it representing our s, height in feet, or is it projecting the seconds or time? So since it's talking feet, we know it's height. So we can take our equation and this is going to be your s. So we're going to say 50 equals -16 t squared plus 100 t. So we're going to move everything over here because I want the 16 to be positive. It just makes life a little bit easier. So we're going to move the 16. So it'll be a positive 16 t squared. We're going to move the positive 100. So that's going to make it 100 negative plus 50 equals 0. All right, so let me go here and find my, there we go. All right, so now what I know right off the bat is all of these numbers, because you always want to try to make these numbers smaller before you start doing anything. It just makes life easier. Since everything's divisible by 2, we're just going to divide both sides by 2. And I really hope this line isn't where it's cutting off my video. I'm going to be so mad if I have to redo this. All right, 16 divided by 2, that's 8t squared. 100 divided by 2 is -50t. And 50 divided by 2 is 25 equals 0. All right, so now what we're going to do is we're going to plug this one into the quadratic formula. So where we identified that stuff last time where we did the A's, the B's, and the C's. So here we know that A is 8, B is -50, and C is 25. So let's plug that in and see if I can make this right skinny. So we are looking for T. T is -b plus or minus the square root of b squared minus 4ac divided by 2a. All right, so b is -50, so I'm going to put the -50s in those first 2 placeholders. These 2 are your a's, and this last one is our c. All right, so this is t equals -50 is 50. 50 squared, so 50 times 50 is 2,500. And now I've got 4 times 8 times 25, which is 800, and that's minus 800, divided by 16. All right, so we've got 50 plus or minus the square root of 1700 divided by 16. So what I'm going to do, since we're talking about time, we're just going to plug it in the calculator, because you're not going to tell somebody the time using square root. That's just crazy. So we're going to first look at 50 plus the square root of 1700 divided by 16. And we've got 50 minus the square root of 1700 divided by 16. So I'm just going to type in the calculator. So 50 plus the square root of 1700, enter, divided by 16. So this is 5.7, and this one is going to be 50 minus the square root of 1600, or 1700 divided by 16. And this one is, so t equals 5.7 and t equals 0.55. So now I know both solutions are acceptable since the projectile reaches 50 feet twice. Once on its way up, so think about a grid. Okay, let me do this. So we are projecting this, and it says that so when you shoot this, it's going to go up, and what comes up must come down. So if this were the 50-foot mark, okay, so this is the 50-foot mark, then across here on the way up, so in 0.55 seconds, it's reaching 50 feet, and then it gets to the tippy top up here, and then it comes back down, and then 5.7 seconds, it's at 50 feet again. So you have two correct answers here because the projectile goes up and has to come down. All right. Now the next question here says, I keep losing my mouse, I'm so sorry. The next question says, how long will it take for it to return to the ground? So go back to my lovely photo here. So we projected it when it was on the ground, so that means the height is 0. And if I shoot it in the air and it comes back down, how long till the height is 0 again? So how much time has passed? So now we're going to solve for time again, but this time, instead of our height being 50, our height is going to be 0. So now we've got negative 16t squared plus 100t equals 0. So I'm going to, first of all, I know both of these numbers are divisible by a -4. And they're also both divisible by a t. So if I were to divide both sides by -4t, so think about -16 divided by -4 is 4, and t squared divided by t is t. So we've got -4t times 4t, which gives me -16t squared. Now 100 divided by -4 is -25, and t divided by t is nothing because it only goes in one time. So now I've got two pieces, just like we did a while ago. We had the two pieces. So I have -4t equals 0. So if I divide by -4, I get that t is 0. So we already knew when you go back to that picture, that is so lovely to look at. At the very beginning, when time was 0, the height was 0. Well, we just now saw that. We saw it mathematically. Now what about this one? 4t minus 25 equals 0. So move that 25 over there. So 4t equals 25. Now divide by 4. And you get that t is. So now we're going to go 25 divided by 4, and that is 6.25 seconds. So we know that it's going to take 6.25 seconds for that projectile to go up and hit the ground again. All right. So let's see, how close are we? So this is our last piece. All right. So the IROD trolley service carries passengers along the International Drive Resort area of Orlando, Florida. The graph, so let's go over here. So the line graph, so we got this line graph here. It shows the IROD trolley ridership data in millions. So the quadratic equation is y equals negative 0.00645 x squared plus 0.103x plus 1.62. So this models ridership from 2000 to 2018, where y represents the ridership in millions and x equals 0 represents the year 2000. So if x is 1, that represents 2001. So this would be when x is 18 to represent 2018. All right. Use the model to determine the ridership in 2018. So that means x is 18. Compare the result to the actual ridership figure in this picture, okay? So we know that if this is our formula and we know that x is 18, then all we have to do is plug it in and let the calculator do the work. So y equals negative 0.00645 times 18 squared, because I'm replacing x with what x is, plus 0.103 times 18 plus 1.62. So we're going to go through, we type it all into the calculator, and we get that y is, so the ridership is approximately 1.4 million. So now if we go back up here, so this would be 15 to 20, so 18 would be about right here. So we go up and we look, and then if you do a straight line here. So from this point, if we look over, it's a little bit less than 1.5 million, and that's what we got. We got 1.4 million. So our math does correlate with the picture. So the prediction is about 0.1 million, which is about 100,000 greater than the actual figure of 1.3. So we got 1, 1, 2, 1, 1, 1, 2, 1, 3, 1, 4. So we're pretty close. The calculator and the picture, it is pretty close. All right, now according to the model, in what year did ridership reach 1.8 million? So think about this problem here. Y was 1.4. So now they're telling me that y is 1.8. So now we're going to work backwards and find x. So we're going to have to use that quadratic formula again, just to keep it, to try to keep to not factor it, because that's going to make it more difficult. So what I'm going to do is I'm going to write this. I'm actually going to take a little picture here and put it on the next page so that I don't have to flip back and forth. So I'm going to take a little screenshot of this formula, and we are going to put it right here. All right. So now, using this formula, y is 1.8. So 1.8 is equal to negative 0.00645 x squared plus 0.103x plus 1.62. If you do not have a calculator, there is a program online called Desmos, and it is an online calculator. It's free. So if you don't have a handheld calculator, that will work. And I can send y'all a link for that. All right, so I'm going to move the 18 over here with the, or the 1.8 over here with the 1.62 so that it can be equal to 0 so that I can get my A, B, and C where I can plug it into the quadratic formula. So if we subtract 1.8 from both sides, we have 0 equals, so is my, I don't know why it keeps going back, negative 0.00645 x squared plus 0.103x minus 0.18. So 162 minus 18 is 0.18. So now I have my A, my B, and my C. So we're going to plug all of this into the quadratic formula, and it is going to look very messy. So what I'm going to do is do the little snippet to put over here so that you don't have to read my messy writing. All right. So we're going to all right, so now plugging it in. So here is our negative b squared plus, or negative b plus or minus b squared minus 4ac over 2a. So now we can type all of that into our calculator and get, when you type it all in, it will just give you the answer. Obviously, you do it one at a time. So these are the two answers that you will get. So x is 2 or x is 14, approximately. So in the year 2002, because remember when x is 2, that represents 2 years after 2000. So this would say, this would be in the year 2002 and in the year 2014. So according to the model, the ridership reached 1.8 million in the year 2002. This outcome closely matches the line graph. So if we go back to that picture, so if we're looking at 2002, so this would be 2001, 2002, 3, 4. So if we go to 2002 and we look up, it's a little bit more, and we're looking for 1.8 million. So it's a little bit off. And then in 2014, which would probably be closer to here, and we look again, and it's, so the year 2002 corresponds with the x equals 2. So according to the model, the ridership reached 1.8 million in 2002. This outcome closely matches the line graph and seems reasonable. If this is 18, it's a little bit right there, so it's pretty close. And in 2014, so that would be this line here. So we look up. It seems reasonable compared to the line graph because the number of riders on the on the trolley increases until about 2008. So it's going up and then it starts going back down until, and then after that there's 2 years where the ridership was. So basically it goes down and then it starts to kind of come back up. So both of these answers are reasonable answers. So remember that when you're working with quadratics, those degree 2s mean that you're going to have at most 2 answers. Sometimes in real world, only one of them works. like the geometry stuff where we had the negative numbers. And then sometimes in real world, both numbers will work because things tend to repeat. Please reach out to me if you have any questions or want me to go over anything specific, and I will do my best to get that answer back to you as quickly as possible. Have a great day.